This next set of problems asks you to state the maximum number of terms in the graph. So that's the maximum number of turning points that the graph could possibly make, and describe the end behavior. So describing the end behavior is something we've done many times. Stating the maximum number of terms might seem something new. So what you're going to do to state the maximum number of turns is quite simply the max number of terms is equal to 1 less than the highest exponent. I'm going to make that even simpler. The highest exponent minus 1. Highest exponent minus 1. So we're going to look for the highest exponent. Let's do number 5. We're going to look for the highest exponent. The highest exponent is 3, meaning this is a degree 3. Therefore, the max number of turns will be 3 minus 1, which is 2. So if my highest exponent is 4, the max number of turns would be 3. If my highest exponent is 7, the max number of turns would be 6. Now when it says turns, that means turning points. So turns means turning points. Now it also asks us to describe the end behavior. Because this is a degree 3, which is a cubic polynomial, the ends are going to be doing different things. So in this case, because we have a negative leading coefficient, the left end is going to rise and the right end is going to fall. So that means as x goes to the left, y goes up. As x goes to the right, y is going to fall down. And sometimes they put y as f of x. Sometimes they put it as y's. In this case, my guess would be because it's in function notation, they would use f of x here and not y. But in case you're familiar with seeing the y's instead of f of x, I want to be able to address that right here. So maybe on the next one, I would put f of x approaches instead of y approaches, just so you're familiar with both ways to write that output of a function.